Hey kids, this is Metric Conversions Additional Practice number 2. Like practice number 1, I'd like everybody to write down the following 3 problems, leaving space in between for you to solve them. And when I tell you to press the pause button, go ahead and press pause. Copy the problems, answer the problems, and then when you're ready to see the answers and check your work, press play again. Sound good? So go ahead and press pause now. The first problem asks us if we have 0.250 liters, how many nanoliters do we have? As always, we start by writing 0.250 liters as the top of a fraction. And this is a single step conversion because we're converting from liters, which is a base unit, to nanoliters. Put liters on bottom, nanoliters on top, and then we fill in our metric conversion. If we follow the metric conversions chart exactly, we know that nano means 10 to the negative 9. And if we're going to use the metric conversions chart exactly as written, you always put that power of 10 with the base unit, in this case liters. So 1 nanoliter is equal to 1 billionth of a liter. The other way we could have set it up, if you don't like negative exponents, is 0.250 liters is multiplied by, again, nanoliters over liter, because we always want the liters to cancel. We follow the diagonal rule. But we could have used 10 to the positive 9 on top and 1 on bottom, because both of these are true. There are a billion nanoliters in 1 liter. You could also make the liter smaller. 1 billionth th of a liter is equal to 1 nanoliter. In either case, we get the same answer. We're moving the decimal place 9 places to the right. And if we put this in scientific notation, that's 2.50. That's moving the decimal once this way. And 0.250 times 10 to the 8th nanoliters. Because if we've already moved 1 space to the right, we only need to move 8 more. 2.5 times 10 to the 8 nanoliters. Our second problem, 85 centigrams is equivalent to how many micrograms, is a double step conversion because we're converting from one metric prefix to another. If we write 85 centigrams first, we will convert the centigrams to grams, and then the grams to micrograms. Again, I always like to put my units in first, so that I can be sure that they're going in the right place and that they cancel following our diagonal rule. Centi means 10 to the negative 2, and if we're going to use that exactly, we have 10 to the negative 2 grams per centigram. And micro means 10 to the negative 6. And as before, if we're going to use our power of 10 literally, we put it with the units place. If we want to use only positive exponents, we could have written this as, grams to micrograms. We could have written this as, well, in 1 gram there are 100 centigrams, and in 1 gram there are 1,000,000 micrograms. Again, we get the same answer either way. It just depends on how you would like to write it and how you like to see it. If we move both of these powers of 10 up to the top so that we can add the exponents, if we flip this negative 6 up to the top, it becomes 10 to the positive 6. So 85 times 10 to the negative 2, and then plus 6. So 85 times 10 to the positive 4, or if we're going to write it in scientific notation, 8.5 times 10 to the 5th micrograms. Our last problem in the set asks if we're walking, let's say, at a rate of 2 meters per second, that's like a speed walk. If we're walking at 2 meters per second, or jogging, how many kilometers per day will we move if we keep up that velocity, if we don't break that pace? Well, I like to write this as 2.0 meters per 1 second. Because when you go 60 miles per hour, you're really going 60 miles per 1 hour. So we like to separate these units out and put a 1 on the bottom. Again, when you look at this really means kilometers per 1 day. Let's convert seconds to days first. So I know that there are 60 seconds in 1 minute, and I know that there are 60 minutes in 1 hour, and I know that there are 24 hours in 1 day. If I cancel my units, I notice that all of my time units cancel except for days on the bottom. And next, I want to convert meters to kilometers. And 1 kilometer is equivalent to 1,000 meters. When I do this math, I'm going to take 2 times 60 times 60 times 24, and then I divide it by 1,000 because that's on the bottom. And when I do that, I get, looks like I get 173 kilometers. So, if I walk or jog at a pace of 2 meters per second, then I will have walked 173 kilometers if I did not stop and take any breaks that day. And that's the end to this practice session.